Hi guys, Mrs. Delisin here. Welcome to another lesson of Algebra 2. Today, we will learn how to determine whether something is or is not a polynomial function. We will also learn to determine the degree and the leading coefficient of a polynomial function. So, the definition of a polynomial function, the degree of a polynomial is the value of the largest exponent. So, when you say largest exponents, if you have 2x to the power of 5, 5 is what you call the exponent, and then 2 is what you call the coefficient. Okay? And if you have 4x to the power of 6, 6 is what you call the exponent, and then the 4 is what you call your coefficient. So, the degree of a polynomial is the value of the largest exponent. We'll have an example later on. The leading coefficient of a polynomial is the coefficient of the term with the largest exponent. We also have two important notes regarding polynomials. The exponent for the x term must be non-negative integers. So when you say non-negative, you're looking at 0, 1, 2, 3, 4, 5, 6, right? So technically, it cannot be a fraction. It cannot be a decimal. It cannot be 1/2, 1/4, 1/3. And it cannot be a negative number also. So all exponents must be positive integers. And then, you also have to recall that x to the power of 0 is equal to 1, and x to the power of 1 is equal to x. So, I would like you to remember that because later on, we'll find examples where, oh, where's the x? That means the x was x to the power of 0, and then that's equal to 1. So, I would like you to highlight that in here also. Polynomials cannot have multiple variables mixed together. What does that mean? So if x is the input variable, then we cannot have a y mixed with x in the expression. So let's have an example of, so we can determine if a certain term is a polynomial or a certain equation is a polynomial or not. Okay. So for example number 1, for r of x, so we have r of x, s of x, and then we'll compare. We also have f of x in example number 2. So let's focus on r of x first. I'm going to highlight that one in there. So we have r of x is equal to negative x to the power of 4 plus 3x to the power of 3 minus 2x squared plus x minus 1. And remember, we need to state the degree and the leading coefficient. According to the definition earlier, the degree of the polynomial is the largest exponent. So let us compare our exponent. We have 4, 3, 2, and then x to the power of 1, and then this one is x to the power of 0, right? And that's the reason why there is no x value in it anymore. We call it the constant. So, because this term right here has the largest exponent, 4 is our largest exponent, the degree of our polynomial is 4. And it also says earlier, let me go back quickly, okay? It also says earlier that the leading coefficient of a polynomial is the coefficient of the term with the largest exponent. So, because the term negative 6x to the power of 4 is the one with the largest exponent, and that's why our degree is 4, we will also find our leading coefficient in there. And so our coefficient is negative 6. So the leading coefficient is negative 6. Now, I would like to remind you that 3 is a coefficient. Negative 2 is a coefficient. Positive 1 in the 1x is also a coefficient. But we're not looking for just the coefficient. We're looking for the leading coefficient. Okay? Moving on to s of x. We have 14x to the power of 5. And again, we will state the degree and the leading coefficient. So in this case, I will find the one with the largest exponent. And it looks like, I know 14x to the power of 5 is written first, but that's not the one with the largest exponent. It's the negative 12x to the power of 7 owns the largest exponent. So our degree is 7, and our leading coefficient is, of course, where we found our largest exponent, that's where we will find our leading coefficient, which is negative 12. Okay, example number 2. Explain why f of x, h of x, and h of x, and we also have g of x in there. Explain why they are not polynomial functions. So let's start with f of x. Remember, in our definition earlier, we cannot have a negative exponent. The term x to the power of negative 3 has a negative 3 as an exponent. And that's the reason why f of x is not a polynomial function. Moving on. G of x. What is wrong with g of x? G of x does not have a negative exponent, but it has a fractional exponent. It has a 1/3. And remember, for it to be a polynomial, the exponent must be a positive integer. And so, this is not a polynomial function because it has a fractional exponent. Moving on for h of x. 2x to the power of 4y plus x cubed minus 1. This one does not have a negative exponent. It does not have a fractional exponent, but it's using multiple variables. And according to the definition of the polynomial, it cannot have mixed variables. So this is not a polynomial function because it has both x and y in it. Okay? Let us have a practice example. For each of the following, state whether or not it is a polynomial function. Then, if it is a polynomial function, you state the degree and the leading coefficient. If it is not a polynomial function, you briefly explain why it is not. So for letter A, we have, let's take a look. Do we have a negative exponent? No. Do we have a fractional exponent? Do we have multiple variables? So all of those are no, 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 no. That means that this one is a polynomial function. And because it's a polynomial function, we will find the degree and the leading coefficient. Remember, the degree of the polynomial is the largest exponent. So the largest exponent here is a 3. And so my degree is a 3. And then my leading coefficient is 7. So LC means leading coefficient. Moving on for B. No negative exponent, no fractional exponent, no multiple variables. This means this is a polynomial function. And because it's a polynomial function, we will have to say the degree and the leading coefficient. So the degree is the highest exponent, the largest exponent. In this example, the largest exponent is a 6. So my degree is 6, and then my leading coefficient is 5. Okay, moving on. For letter C, we have a negative exponent. That means this is not a polynomial function because of the negative exponent. And because this is not a polynomial function, then we don't need to have a degree and a leading coefficient. Letter D, it doesn't have a negative exponent. It does not have a fractional exponent, but it's using multiple variables. So this is not a polynomial function. Okay? Now that we know the degree of a polynomial and the leading coefficient of the polynomial, we are now studying different kinds. Oh, we have more examples, E and F. So we have, before we move on, it doesn't have a negative exponent. It doesn't have a fractional exponent. So it is a polynomial with the degree. Look for the largest exponent. In this case, this is a 4. But you know how this whole entire thing, it has a 3 at the bottom. That means This one is negative 1x. There you go. Right? So it's negative 1/3 x to the power of 4. And that's the reason why the degree is 4 and then the leading coefficient is negative 1/3. For letter F, we have a fractional exponent right here, 1/2. So this is not a polynomial function. Okay. In this example, we are now looking at different kinds of we will learn the degree and the leading coefficient of a polynomial, and then we're gonna now determine the end behavior of a polynomial. So let us describe the common behavior we observe by filling in the blanks. So here we have the graph of a polynomial function with a degree of 0. Oh, how did I know that the degree of this is 0? Remember, I highlighted earlier that when x is equal to 0, it's equal to 1. Right? And so in all of these examples, this one has x is equal to x to the power of 0. So x is, it's usually the degree of this one, the degree of this is 0. So the graphs of a polynomial function of degree 0, these are called horizontal lines. And if you don't notice that the graph is right here. And then the graph is right here. And then for here, of course, y is equal to 0. The graph is the x-axis. And these are called horizontal lines. And we are so familiar with that. Moving on. This one you are so familiar with also. We call this one with a degree of 1 because this is x to the power of 1. Negative 2/3 x to the power of 1. 2x to the power of 1. So the largest exponent is 1, and that's why the degree is 1, and they are called diagonal lines. Now, I would like you to notice here, do the left and right ends of each function head in the same, opposite direction? So when I say the same or opposite direction, here's what I'm trying to say. On the left side, you're ending down. But on the right side, you're ending up, right? So you're increasing to the right, decreasing to the left. That means that even here, increasing to the left, decreasing to the right, increasing to the right, decreasing in the left side. And we can see here that our left and our right behavior, they end on opposite direction. And you also have to notice that when the leading coefficient is positive, it increases to the right. So it increases to the right. So this one also, if you take a look, it increases to the right. So your leading coefficient is a positive. Here, it decreases to the right. So our leading coefficient is negative. Right? And you know there's a positive slope and negative slope thing. Moving on. We have here a degree of 2 because of that 2, of these two right here. The graphs of a polynomial function with a degree of 2 are called parabolas, and we're so familiar with this. Do the left and right ends of each function head in the same or opposite direction? And we can see that they are both up, they are both up, they are both down. So if the right is up, the left is up. If the right is down, the left is down. Does that make sense? So they end on the same direction. The arrow is in the same direction. If the leading coefficient is positive, so in this case, this one is leading coefficient positive. This one leading coefficient is positive. Miss, I forgot where the leading coefficient is. So the leading coefficient here is there, positive 2. The leading coefficient here is negative 1. And when the leading coefficient is negative, the graph opens down. When the leading coefficient is positive, the graph opens up. Okay, moving on. We have here the graphs of a polynomial function with a degree of 3 are called cubic graph. Do the left and right ends of each function head in the same or opposite direction? I think you can now tell that they head on a different direction, right? On the right, it's up, but on the left side, it's down. So this one is also heading in different direction. So if the leading coefficient is positive, the graph increases to the right. So because the leading coefficient of this and this one are positive numbers, so the leading coefficient here is positive 2, negative 1, positive 1. So if the leading coefficient is positive, it increases to the right. Now on the right side, it's going up. But if the leading coefficient is negative, on the right side, it decreases. Okay? Last two more. We have what we call the graphs of a polynomial function of a degree of 4. Where is 4? 4, 4, and 4. These are called quartic graph. Do the left and right ends of each function head in the same or opposite direction? I think you'll know by looking at it that both of the direction for both left and right, they are both in the same direction. If the leading coefficient is positive, then the graph opens up. And if the leading coefficient is negative, then the graph opens down. So this is like the parabola one, right? They are exactly the same. Okay, our last one is the graph of a polynomial function of a degree of 5. It's called the quintic graph. Do the left and right ends of each function head in the same or opposite direction? I think it's very obvious. They head on opposite direction. And whenever the leading coefficient is negative, it decreases to the right. Whenever the leading coefficient is positive, the graph increases to the right. Okay. Now, we've learned what kind of degree? We learned a 0, right? So, let's not include 0. So, let's have 1, 2, 3, 4, and 5. And if you notice, the number 2, the degree of 2 and the degree of 4 are the same. They all are on the same direction. But then the degree 1, 3, and 5 are all the same. They head on an opposite direction. That means, let's try to, in here, the end behavior of a polynomial function. So the end behavior of a polynomial function is dependent on two things. It's dependent on the degree of the polynomial and the leading coefficient. When the degree is odd, the right and left end behavior will always be opposite. So when the degree is odd, what is that? 1. So let's make a table. When the degree is 1, 3, and 5, and of course 7 and 9 and 11 all the way, but we're just focusing on small numbers here. So when the degree is 1, 3, and 5, those are odd degrees. The end behavior of your graph is an opposite direction. So when I say opposite direction, it's either this way. Does that make sense? And now it then depends on their leading coefficient. But if the degree is even, what's the one that we have? We had a 2 and we had a 4. If the degree is even, then we only have two. We also have two ways. They either both go in the same direction facing up or the same direction facing down. Now, when the leading coefficient is positive, the right will always be up. So this is when the leading coefficient is positive. Let's change the color. So leading coefficient positive, leading coefficient negative. Leading coefficient is positive, leading coefficient is negative. So that tells us that when we know the degree of a polynomial, we know which direction the end will go. When we know if the degree is even or not, if it's even, we know that they will head on the same direction. Let's take a look at pictures. We're almost done. I know it's kind of like a very long introduction, but it will get better, you guys. So we have pictures over here of what it looks like. But let us And you can review this on your own, of course. So when the degree is odd and the leading coefficient is positive, so the right end behavior is up, the left end behavior is down. So let's take up, I know there's also a picture in there. So when the degree is odd, you know it's opposite direction, and the leading coefficient is positive, so you know it's going to be like that. When the degree is odd and the leading coefficient is negative, we know it's going to be like this, decreases on the right. When the degree is even and the leading coefficient is positive, so we know it's going like this. When the degree is even and the leading coefficient is negative, we know it's going to be like that. So there are only four different things that could happen to the graph. So you just pick which one will happen based on what we're given. So, okay, let's try to check. So for each of the following function, you state the degree, leading coefficient, and the y-intercept. Then you have to draw a sketch following only the end behavior of the graph of a function. So these are all polynomial functions. So this is not where, you know, earlier we tried to determine if it's a function or not. If it's a polynomial function or not. In this case, these are all polynomials, so we don't have to worry about that. We have to worry, though, about the degree, the leading coefficient, and the y-intercept. Let's start with the degree of the polynomial. The degree of the polynomial is the largest exponent. So let us find the largest exponent first. So it looks like x to the power of 3 is, or x cubed, is the term that holds the largest exponent. And that's the reason my degree is 3. And you know 3 is an odd number. If that's a 4, I would say it's even. But 3 is an odd number. And because it's odd, I know that my graph will be on an opposite direction. But there are two kinds of opposite direction. One like this, and one like that. So we need to know which opposite direction is the graph that we have right here on letter A. So we also need to identify our leading coefficient. Is our leading coefficient positive or negative? In this case, the x cube has a 1x cube, so it's a positive 1. And so my leading coefficient is positive, and so my sketching increases to the right. If my leading coefficient happens to be negative, then my graph would be on the opposite side like this. Right? Okay. Now, where did I get that y-intercept 0, -5? Remember that y-intercept, you will get the y-intercept by plugging in 0. So if I plug in 0 though, 0 cubed is 0, -4 times 0 is 0, 7 times 0 is 0. So technically, the c value or the constant value is your y-intercept. So that is my y-intercept, 0, -5. That's my y-intercept, 0, -7. Okay? Now, let's find the degree of the polynomial in here. The degree of the polynomial is the largest exponent, which is 4. We know 4 is an even number. And so I know that my graph will head on the same direction. I have two graphs that ends on the same direction. Like this is the same direction, and this is also the same direction. So what we need to do is to find out what the leading coefficient is. And that is -2. Because -2 is the leading coefficient, I know that this graph is facing down like this. And that's the reason why I drew two arrows going down. Okay? And hopefully you can do the rest of them. And in here, I'll just give you an example. For each of the following polynomial graphs, state whether the polynomial is even or odd degree and whether its leading coefficient is positive or negative. Okay, first, is it on the same direction or opposite direction? Because it's on an opposite direction, I know that the degree of this is odd. And because it decreases to the right, you see it's decreasing to the right, I know that my leading coefficient is negative. Moving on to letter B. Because it's the same direction, they're both up and up, I know my degree is an even number. I do not know what the degree is, if it's a 4, if it's a 6, but I know it's an even degree because they end on the same direction. And because they're facing up, they're opening up, not down, I know that my leading coefficient is positive. Okay, I hope that this lesson is not so confusing. If you have any questions, let me know. And thank you guys for listening. I will see you guys on the next video. Bye.